Or when they're real, brings in the next one, humidity. When the humidity is really high. There again, there's no place for the water to evaporate, so it doesn't into the air, it ends up on the ground. So high humidity can be a real advantageous thing to the sprinklers. So we have all these weather-induced effects on what's happening to that water. So temperature, solar radiation, humidity. We have really high humidity, we will have virtually no evaporation. The reason is the air is already saturated with water. There's no place for more water to evaporate to because the air is already full of it. And all that the world is doing is balancing energy levels. And those water droplets are simply trying to balance themselves between becoming vapor and falling to the ground. And if there's not enough energy in the air to convert that droplet from a liquid to a vapor, it'll hit the ground as a droplet. If there's enough energy in the air to convert it from a droplet to vapor, it'll evaporate and never hit the ground. So those are the factors that you have to look at. Now, how you can get away from some of these things is by the length of time we let the droplet stay in the air. There again, we get back to some of the other practices. Low angle. Don't let it hang up in the air so long and drift out there. Get it on the ground quicker. Drive it out there and get it on the ground without as many parts of a second exposed to the atmosphere. That's a way to help. Drop the pressure so we get bigger droplets. Again, we can't drop it too much because we'll get that darn splatter effect out of those great big huge droplets. But we don't want to have itty-bitty droplets because, again, it's a relationship of volume to surface area. The bigger the droplet, the more volume per surface area you have, and the more is going to make it to the ground because you have less area to evaporate per volume of water as the droplet gets bigger. So you'll have less overall evaporation when that occurs. Of course, we get that drop too big, then we're going to have compaction problems. Also, wind is the other player that is, and we've talked about wind already, the other climatological player in this thing. And again, droplet size is a lot to be doing with the effect of wind. And we've already talked about that one just a little bit ago. But so we have these climatological conditions. You know, it's going to be different when we're irrigating in the middle of July than when we're irrigating here, say, in September or October, because we have a whole different condition. In July, in this part of the country, we have our longest days, we have our hottest days, we have our greatest sun intensity, we have our lowest humidity, so therefore we're going to have our worst efficiency during that month. We get into the fall, the humidity picks up, the days are shorter, there's less heat in the air, there's less total solar energy to fight getting water into the ground and to the plant. Any questions on the climatological effects?